We are ready for our next assumption, the last one for today. We saw that when the motors are set to the same speed, the robot drives forward in a straight line. What do you think will happen if both motors run, but at different speeds? Remember that we already concluded that if one motor is set to a speed of 0, the robot will start turning towards that motor, and that wheel will be the center of the circle. So maybe this is a similar case. Try to imagine what would happen if the right motor will turn slower than the left motor. Send us your assumptions in the chat. Think about that shopping cart that has one wheel stuck. What will happen, you think? Let's have a look at those comments. Excellent, excellent. Excellent. To try out this hypothesis, I'm going to move on to the navigation, part 6. Making assumptions based on past experiences is critical to the learning process, as this promotes higher order thinking skills like synthesizing. To make this a bit visual, I have prepared a code that does something very basic. Give me a second while I open it. This program starts by driving both motors at the same speed, but then starts to gradually lower the speed of the right motor, a bit like applying the brakes, but to only one motor. So after a few seconds, the right motor will stop altogether. We can already foresee what would happen then, having just the left motor turning. Let's run it and observe what happens. As you can see, the robot started in a straight line, but as the power to the right motor drops, the robot curves to the right. Actually, what happens is that the radius of the turn drops from infinity, which is the radius for a straight line, until the right motor stops. At that point, the turn diameter equals the distance between the wheels. What we get is a lovely spiral. Each curve in the spiral correlates to a different right motor speed. We now have something new to add to our rule book. A bit hypnotizing, isn't it? Here is our rule book again. Let's see what we have. Driving both motors at different speeds will drive the robot in a curve towards the slower motor. We can also add that the turn radius is in opposite correlation to the difference in speeds between the two motors. So, the higher the difference, the smaller the turn radius. This is a great rule. We can now apply it to our navigation mission number 6. While there are many ways to solve this mission, the path of collectibles implies that we should drive in a curve. Since we figured out we should just slow down one motor, I will try driving the right motor at a speed of 50, while keeping the robot the left motor at top speed. So let's set the speed for the left motor at 100 and 50 for the right motor. I'll run the code and let's see what happens. As you can see, the robot is turning, but the curve is tighter than what we wanted. So what do you think? Should I increase the speed of the right motor or maybe reduce it? Write it down in the chat box and we will try again. Okay, so most of you have said to increase. So I'll start with decreasing the speed of the right motor just to spike. Let's write 25. As we can see, the curve is even tighter. So by making a mistake, we actually validated and constructed a new piece of knowledge. If only exams were like this. Now it is time to do right. I may not succeed at my first attempt. Say 80. But that is fine. We know what to do, and all that remains is to adjust the speed to the right value. Almost. Let's add a little bit of speed to the right motor, so the turn radius will be higher and we'll be able to go into that parking. Hooray!